Here I'm going to be looking at coordinate geometry of the line, specifically dealing with the distance formula. This is a Leaving Cert past paper question 2015, and to start with, we're given 2 points, A and B. We're told the coordinates of A, and for B we know the x value is 7, but we're not given the y value, and we have to work it out. And we're told that the line L1 here is perpendicular to the line AB. So if that's perpendicular, we know that the slope of AB is going to be minus the reciprocal of the slope of L1. So my first job is to work out the slope of L1. If the equation is written in this format, ax plus by plus c, then the slope will always be minus a over b, which is minus 3 over minus 4, which is 3/4. So therefore the slope of AB, which is perpendicular to that, we just flip the fraction and change the sign. So the slope of AB then is minus 4 over 3. Well, if the slope of AB is minus 4 over 3, that means the difference in the y's over the difference in the x's is minus 4 over 3. So rearranging this equation, we're left with t is equal to minus 5. So this next part of the question deals with the distance formula. So you're asked to find, in terms of k, the distance between this point, which we're not given its y value, and the line L1, which we dealt with in the first part of the question. So the distance formula is given by the coefficient of x in the line times the x value plus the coefficient of y in the line times the y value plus the constant in the line c, and it's the modulus of that value all over the square root of the coefficient of x squared plus the coefficient of b squared in the line. So we're now told that our point P is on a bisector of L1 and L2, and L2 is this line here. So that means the point P is on the line that bisects these two other lines. Well, if it bisects those two other lines, that means it's equidistant from it, i.e. the perpendicular distance from P to L2 is the same as the perpendicular distance from P to L1. So what I'm going to be able to do is going to be able to create an equation in K, because I know the perpendicular distance from P to L1 is just this value here. I need to then work out the perpendicular distance from P to L2. Well, that's just plugging it into the distance formula. I'm left with 5 times 10 plus 12 times k minus 20 all divided by 13 is equal to this distance there. If we're told that k then in the last question is greater than 0, so that means k is equal to 3/4, find the distance between P and L1. Well, we sub 3/4 into 18 minus 4 times k over 5, and that gives us a result of 3.